everybody, welcome back to Teach Me to Science, and today we're going to be talking about atomic mass and how it relates to isotopes. So first we're going to be defining atomic mass, and then we're going to be talking about what an isotope is, and for the last little bit of this video we're going to do a practice problem to connect these two ideas. Alright, so what is atomic mass? If we break down the word atomic mass, it might become a little bit clearer what its definition is. So atomic mass is the mass of protons and neutrons which make up the mass of the atom. So that's where the atomic mass comes from. Atoms are made of protons, neutrons, and electrons. However, only the protons and neutrons contribute to its weight. Electrons have a mass of approximately 0, or very, very close, which means they don't contribute to the weight of the atom. So the atomic mass is the number of protons and the number of neutrons combined. Just a quick refresher on subatomic particles, which are the particles that make up an atom: protons, neutrons, and electrons. Neutrons are neutral, electrons are negatively charged, and protons are positive. Protons are the defining part of an element. The number of protons is unique to every single element. If you're a little bit rusty on your subatomic particles, then you should check my video on subatomic particles out. I will link it in the little flag above that will appear shortly. So the key concept here is that the sum of protons and neutrons is the atomic mass. Now that we know what atomic mass is, we can talk about isotopes and define them and how these two are related. Isotopes are defined by a change in neutrons. This is very important for the definition. It's a change in neutrons, not a change in protons or electrons. Isotopes are variations of the same element with different neutrons. A common example of this is carbon-13. We're going to be looking at a different example besides carbon-13. So we're going to be looking at an element that has 5 protons and 5 neutrons. However, an isotope of this element may have 5 protons and 6 neutrons. In this case, these two atoms are isotopes of each other because they differ by 1 neutron. It's very important to remember that these two atoms are the same element still because they have the same number of protons, and the protons are what define what element it is. So you may be wondering how isotopes relate to atomic mass. Isotopes relate to atomic mass because an isotope has a different atomic mass or a change in atomic mass from the traditional element. Now that we've defined atomic mass and isotopes, let's do a practice problem which combines both of these ideas. Nitrogen gas is made of nitrogen-13, nitrogen-14, and nitrogen-15 with the relative abundances of 15%, 60%, and 25% respectively. What is the weighted atomic mass? First, let's look at what this problem gives us. This problem states that there are 3 different isotopes of nitrogen: nitrogen-13, nitrogen-14, and nitrogen-15. All of them have varying amounts of neutrons in their nucleus, and respectively they have abundances of 15, 60, and 25%. So what does abundance mean? You can think of abundance in terms of how commonly it's found in nature. So this means that nitrogen-13 is found in about 15% of all nitrogen samples in the world. Same goes for nitrogen-14 and nitrogen-15. So what is weighted atomic mass? Weighted atomic mass is the atomic mass that appears on the periodic table for every single element. It's a combination of all of the different isotopes found in nature and their relative abundances. So to find the weighted atomic mass, all we need to do is find the relative percent abundance of each species and add them together. So to find the individual percent abundances, what we have to do is we have to multiply the atomic mass by the percentage as a decimal. So if we do this for every single species and then add them together, we'll get the weighted atomic mass. So first we're going to multiply 13 by its abundance, which is 0.15, and we'll do the same for nitrogen 14, which is 60% or 0.6, and finally we'll do the same for nitrogen 15, which is 0.25 times 15. So if I do this math on my calculator real quick, I'll find that 13 times 1.5 is 1.95, 0.6 times 14 is 8.4, and 0.25 times 15 is 3.75. If I add all of these numbers together very quickly, I'll find that the weighted atomic mass is 14.1, which is our answer. All right, and that's all I have for today. Thank you so much for watching this video. If you could, please follow me on social media at Teach Me to Science. If you could also subscribe to this channel, I would appreciate it so much. Like this video, and just so you're aware, I have a new Etsy shop that is live. If you search Teach Me to Science with no spaces on Etsy, you'll find my shop where I'm selling all kinds of nerdy scientific stickers. So go check that out. Thank you again for watching, and I'll see you guys next time. Bye!